for hydrogen to work, for carbon capture to work, you need the network, you need the mechanism, the pricing, as well as the consent, the investment. And you've got all of these different things that need to be lined up for that to happen. And I think one of the things that nuclear could potentially do in these kind of more complicated, multifaceted schemes is if we can create an SMR project that is grid connected, that can then be a linchpin that opens up these other opportunities that can come off the back of it. So for example, I've already got my power, so I don't need another connection. You need there to be something that can move first independently of the other aspects of a scheme, and then the other aspects of the scheme can hang off it. And I do think that at the right site, at the right scheme, nuclear can really be a catalyst for some of that broader infrastructure and low carbon investment.
Well, welcome back to the Decarb Connect podcast. And today I'm very pleased to be joined by Andrew Murdoch, who's the Managing Director for newcleo. And the reason that this is a story and a business that interests me is because of this focus on nuclear, number one, but also, as you'll come to hear, nuclear generated from a very interesting source, which has a whole load of clean and circular benefits associated with it. So, Andrew, can I ask you just to give our audience a bit of a feel for how you've arrived at this point in time, working in the energy transition, working in nuclear? What is it that's brought you here?
Hi, Alex, and thank you very much for talking to us today. Much appreciated. So, yeah, I started my career as a materials engineer. I joined the power industry working for npower, as it was at the time, and they were one of the big 6 energy producers. I worked in conventional power generations. We were working on coal plants, and actually I did lots of project roles through the original or the second dash for gas through the early 2000s, where I was involved in building new gas-fired power stations, and then also subsequently retrofitting some of them with efficiency improvements, and then moving into things like biomass conversions of coal stations before I then ended up in nuclear. And my drive really was I liked engineering things. I liked big infrastructure projects. I liked delivering and developing energy projects. And I've since spent over 10 years in looking to develop new nuclear in the UK, initially on large gigawatt scale projects, and then now over the last 2 years I've spent with nuclear, looking at advanced nuclear development. And my perspective is that of being a energy developer in the space of nuclear, and that's been my focus really in the last 15 or 20 years or so.
Okay, good intro. So let's just have a look at the business in brief to begin with, because we will come back to it. But what's this? I mean, it's got quite a unique position in what it's trying to achieve. So just sort of lay the groundwork, and then we obviously will dig into it a bit more later on.
Yeah, so newcleo is an advanced nuclear technology company. We are looking to develop a type of reactor called a lead-cooled fast reactor. So that's 2 things. One is we are using liquid lead as the coolant in the reactor, and there's lots of benefits to that I can come back to. And we are developing a fast reactor, and the fast reactor means that we can fission a wider range of radioisotopes than conventional light water reactors and thermal reactors. And that opens up the possibility to do what we plan, which is to use nuclear waste and existing nuclear materials to make a fuel for our reactor, which we call mixed oxide fuel. So in essence, our reactors can operate using materials that already exist. We eliminate the need to mine new uranium products, and we don't produce new waste other than what we call the fission fragments from the fission reactions, which are low, sort of short-lived wastes. They're sort of 300 years, not tens of thousands of years, as is the case with uranium and plutonium remaining wastes and the various minor actinides. So, as I said, we produce a essentially low waste nuclear proposition that avoids the need for additional mining of uranium.
I think the thing when I think about this for our audience and for what Decarb Connect does, what I like about the tech and the story that you're developing is it's not just about that kind of clean power, and we'll talk a little about what it will take to create a zero carbon or the lowest possible carbon plant in a moment, but it is this thing about how this kind of virtuous circle, I suppose, that you're not leaving so much in the footprint of the business. And I think that once it's at scale and once it's delivering power to industry is very appealing for people who are finding it quite challenging actually to sort of find any source to decarbonisation that doesn't seem to come with some kind of penalty, either financial or material or something else. But let's dig in a bit more then. So I mean, the industrials listening, the investors listening, people are familiar, obviously, with nuclear in its current role, certainly in the UK. They probably have some understanding of modular reactors, which is probably the way that most of our industrials talk about nuclear at the moment, or those that are thinking about it. That's been the thing that's come to them in the last 12, 24 months. But nuclear generated from nuclear waste, a clean and a circular fuel, like how did this even start? Because it's not the most obvious. Is it? I don't know, maybe it is, but it's an interesting kind of proposition to have built a platform on. So what was it rooted in?
So let's start with our founder, who's our founder and CEO, a guy called Stefano Bueno. He's an Italian nuclear physicist originally, and has spent many years working in CERN under Nobel laureate Carlo Rubbia. And he was working in the area of sort of what we call transmutation of nuclear waste. So how do you turn nuclear waste into something which is less long-lived? And they came up with the concept of what's called an accelerator-driven system, where you combine a particle accelerator with a subcritical nuclear reactor, so that it is intrinsically safe. You turn off the accelerator, and the nuclear reaction stops effectively immediately. And they were looking to identify how to do that, and lead came up as a coolant, as to an opportunity and a really ideal solution to an accelerator-driven system. And that really got Stefano introduced to lead, and that's where he met, who is now our chief scientific officer, a guy called Luciano Sinotti, who subsequently spent, and had to that date, spent many years working in both fast reactors using liquid metal coolants, and then identified lead as a solution, and spent the last 25 or more years working in research and development into liquid lead fast reactors. Stefano subsequently left CERN, acquired the rights to use a patent, created a very, very successful company in nuclear medicine and radioisotopes called Advanced Accelerator Applications, which he sold in the sort of 2015, 2016 to an American company for around about 4 billion, obviously netting himself a sizable fortune himself. But actually, rather than kind of taking the easy route there, he had always wanted to come back and create a nuclear technology company, and had always seen the potential for fast reactors to be combined with closing the fuel cycle and essentially create a new next step in the nuclear fission industry. And that's where we are. So in 2022, he founded the company. He raised an initial 100 million pounds, 100 million euros, forgive me. Subsequently, raised a further 300 million euros. So all of that in the first year of our operation, and established newcleo, built a very strong team. We're growing very rapidly. We're over 650 people now. We are just over 2.5 years old. We are growing very fast. We are the sort of most privately funded nuclear startup, probably the most privately funded energy startup in Europe. And we have a very ambitious program, but also a very compelling long-term vision, as you've described, of using liquid lead fast reactors fueled by nuclear waste to close the fuel cycle and create, very, very clean energy, and potentially waste-free I use that loosely, waste-free energy for new entrant countries into nuclear, but also providing a potential solution for countries that already have an existing stockpile of spent fuel.
So then let's take it to the next step in that. That's a really great introduction to the company. You've got, I mean, for a 2-year-old business, you know, that's an impressive manpower line to have up and running. What is it that they need to do? What is it that you need to do? Or what is it that we need to do to create, you know, that zero carbon plant, that first plant? So later on, we can talk more about investments and partners, but technically, and also in terms of the system around it, as in the energy system, what's needed for this to really be up and running, switched on, providing power?
So our plan goes through a program of research and development into technology demonstration and then realization. So, you know, the first stage is we're very focused on R&D, and we're intending to have online in 2026 what we call a precursor plant, which is being built in Bracciamone in Italy, in collaboration with ENEA, which will be a scale operating version of the reactor, non-nuclear, because it will be built in Italy, and Italy are currently not a nuclear nation. And that will be used to demonstrate many of the safety and functional aspects of the reactor in operation using molten lead loops. In around 2030, we aim to have a operational 30 megawatt nuclear power plant in France, which will be a demonstrator of the LFR. And of course, we have to fuel that reactor. So we are focusing on building a mixed oxide fuel manufacturing facility of an initially small capacity that allows us to fuel that first reactor and prove that you know, the technology works, and obviously demonstrate that that can be delivered safely and cost effectively, which is obviously key. So that's our initial key focus of our program, progressing the R&D, progressing the design, which we're advancing very, very rapidly at the moment, and then subsequently delivering the supply chain that we need for those nuclear components, going through the regulatory approvals in France, which we've already started last year. We're looking at completing the first phase of that through a series of monthly discussions with the French regulators, which will conclude in this summer. And then we aim to move into the next step of regulation in France. So it's a progressive plan that leads to that demonstration in France, both of the mixed oxide fuel manufacturing, but also of the operation of the LFR. And of course, then what we need to do is make that a reality as a commercial fleet of reactors across the various countries in which we find are appropriate to operate and to develop that fleet. And then that perhaps comes back to the other part of your question as to, you know, what do we need to make that happen? You know, we need to build a robust and resilient supply chain. That's clear. But you know, we need, on the other side of it, we need governments that have the vision to support investment in new nuclear, that create the stable framework that allow either ourselves and partners to be investing in the development projects that bring them forward. You know, of course, one of the issues for nuclear, people talk about investment in nuclear. For me, you know, what we need to do is bring as many projects forward as you can, ready to start having that conversation about investment. And then that's about development. That's about having the framework of engagement with different nuclear regulators. It's about the traditional planning and permitting processes you have to go through. It's about creating certainty in how that project can be delivered and then can be remunerated throughout its life to justify the investment. So yeah, that's broadly where we are. Our aim is to have a first commercial operating reactor of 200 megawatt scale by around about 2033.
Okay, so I think what sort of strikes me when you're talking through that, and what struck me when we did our prep call as well, is this emphasis on working with alongside government in France in order to I guess, yeah, kind of not just familiarize them with the tech, but sort of engage them in what's possible. And how do you do that? How do you, how are you finding the best way to engage around that? I mean, on the one hand, you have a government that is comfortable with nuclear. It's not a high drama topic for them. So that's one issue pushed away. But still, it's still, anytime you're bringing a new nuclear technology to market, there must be, quite complex different levels of discussion. So how do you do that as a new a new technology platform? How do you engage?
Yeah, it's a fascinating question. Actually, one of the things nuclear has done particularly compellingly over the last 2.5 years is become part of the conversation, become part of the discussion, and a lot of that goes to Stefano personally, as well as to some of our teams in sort of communications and government affairs. But we are actively engaged at all levels, talking to people, talking to the countries, whether it be government level, politicians, industry stakeholders, all of the various conferences and discussions that are happening around nuclear, and putting ourselves at the center of that. Davos, the World Economic Forum, the IAEA in Brussels recently, lots and lots of support for nuclear growing. What we see in France, even in the last couple of months, was a nuclear policy committee chaired by Macron, extending the activities of reprocessing in La Hague from 2040 to 2100, doubling down on the sort of scale of that, and also new manufacture of mixed oxide fuel, which again is focused on supporting the nuclear startups like ourselves in France. So we've been working and talking to all of the different industry players in France. We've been doing the same in the UK, and then there's also the kind of formal routes to engage with governments. The UK, for example, recently published a very compelling nuclear roadmap that sets out how the UK government expects to hit its 24 gigawatts by 2050, a route to market for nuclear projects in the UK, and a revised siting strategy for nuclear projects, which is very, very different to before. It opens up a much wider range of sites for reactors to be installed, and the route to market very much clarifies the fact that the current regulatory framework and regime is there and is open for advanced and small modular reactors. And so, it really opens the door for investors to come forward and start promoting projects in the UK. Look, similarly in other countries around Europe and beyond, we are actively engaged in working with stakeholders, whether that's potential partners, whether it's with governments, embassies, sharing the benefits of nuclear, sharing the benefits of our technology, and looking at creating the opportunity to partner at certain levels to bring the opportunity to that country.
I just want to take this opportunity to thank our production partner and sponsor, Jano Media, for their support in delivering the Decarb Connect podcast. Over the last few years, they've helped us to facilitate great conversations that connect us with our audience, and their skills and expertise mean that we get to concentrate exclusively on generating the content, the conversations that engage, inform, and inspire. So right now, if let's take the UK as a second level opportunity. France is obviously your first level opportunity in terms of something being up and running. What's the block, or what's the step that you just most want cleared? Like, what would make a real difference to your ability as a developer of these massive projects to make a clear step forward?
I mean in France, as I said, we've made significant progress. There's a number of signals that we will want from France. we were successful in what's called France 2030, which is their significant program of investment focusing on new technology and particularly low carbon technologies. And we were successful as one of the first companies to be awarded something under that. And that really opened the door to sort of further and extensive dialogue with France, which is ongoing. I mean, the key thing that any nuclear project needs is we need to confirm sites. And again, in France, that requires a declaration from essentially this nuclear policy committee headed by Macron. So, for us, that's key, is getting the confirmation of the site. And that then allows us to continue the regulatory engagement and move forward with the site-specific activities that we need, environmental survey, site-specific design, seismic conditions, all that sort of stuff. So, as I said, in France, that's moving forward. In the UK, the framework's very different. Is much more down to a developer to fend for themselves. So again, our focus in the UK again is on siting, securing the right site, which would be much more commercially focused in the UK than it is in France. And once we have the right site, it will be about entering the various regulatory processes. One of the things that we're asking for in the UK is that so previous projects have had to go so far through the development program, almost to a kind of final investment decision ready state, before they get any concrete confidence from government that that project is supported, whether it's by a kind of revenue support mechanism or the various nuclear liabilities or spent fuel decommissioning agreement type commitments that are required from government. And one of the things that we've been asking for is that that's brought further forward in the development, so that, of course, the pressure still needs to be on all energy projects to focus on cost, to focus on maximizing the value for money and the benefit that project can bring. But actually, what we've seen is that development program in nuclear is really long. It's at least 5 years. I mean, it's a long time for all nuclear all energy projects, but particularly so for nuclear projects. And that investment required, without having the confidence that your project is something that government supports, the government is willing to support, is untenable. Really, we need that to be brought forward, not just for us as nuclear, but obviously for all projects promoted in the UK.
Well, you mentioned before something, a little about the French incentives and the new tech incentives. In general, are you seeing the kind of the governments or the locations that you have in mind, are the right kind of incentives emerging, something different needed? What's your, again, sense specifically for nuclear, for what's really needed to get this moving?
Yeah, I mean, we've often said as an organization that we will privately fund nuclear development, but of course, if incentives are there, we are very, very open to receiving them. What is needed is, to some degree, certainty, because you've got to be able to plan on things being there. I think I don't confess to be an expert in France, and there are many others in our team who are. Again, if I take the UK as an example, there are many opportunities that could be explored that aren't. So, for instance, if you take oil and gas, there are lots of incentives available for oil and gas producers to decarbonize upstream. And there are tax breaks available that allow them to effectively reinvest their profits into that decarbonisation. If you take that as an example, there could be an opportunity for heavy carbon producers, steelworks, for example, or other such organisations, to invest in nuclear and have similar tax breaks from the opportunity to invest in development of nuclear, or other low carbon tech, which promotes that seed investment, that development phase investment where the risks are highest, and gives organizations tax credits for the benefit of doing so. France has a slightly more advantageous R&D tax situation than the UK, for instance. So you can receive benefits for investments in R&D in France that are higher than other areas. So there's various reasons why we are currently focusing a lot in France.
Just out of interest, do your conversations at the moment take in, like, are you at a stage where engaging with industrials specifically is valuable, or is it really more about, actually, no, we're 100% focused on getting this kind of system around us set up, getting the right, well, obviously the sites and project landscapes? Are industrials in the conversation?
Yeah, we're pretty broad, and we're exploring many different areas at the same time. So we have a collaboration with an Italian company called Tecnimo, who are they do a lot of work in kind of oil and gas, but they're exploring hydrogen and e-fuels using electrolyzers, and we have a collaboration with them looking at using LFR to power that chemical process, which again is really exciting for us. I think the opportunity of using SMRs for decarbonizing heat and energy intensive industries is, it's really exciting. It's certainly in the, as I referred earlier to the UK route to market consultation, that was very heavily weighted around the benefit that nuclear can bring to decarbonisation of these kind of high energy intensive industries. And of course, with advanced technologies, you have a higher temperature, and therefore you can do more combined heat and power applications. So yeah, we're actively engaged in that, certainly with, as I said, this collaboration we talked about. And as we're going around the UK looking at siting options, not just for a first site, but for other future opportunities, there are a number of, kind of these potential, what you might call energy hub type solutions, which come to light, where you have, some linchpin looking to bring together different industries to create a collaboration between high energy user, whether that's data center, whether that's existing heavy industry, hydrogen, existing networks, and some form of clean power like nuclear, which can be dense and co-located with that industry. So again, that's an exciting area that we are actively engaging with on the ground as well as on paper.
I'm sure in those conversations, and I know you have MOUs in place as mentioned around green hydrogen, green chemistry. Sure, I mean, I imagine that the number one question ends up being about how cost competitive the final cost of electricity, cost of power is going to be. So what's the answer that you're able to give on that now? Obviously it's still early stage, but what's the kind of the projections?
So on a simple cost of power basis, our analysis is that we're driving the simplest design that we can, and this and cost is relating to complexity and scale. So we're focusing on creating a design which is, our design, we operate at atmospheric pressure. That means we don't have really thick forgings. We have significantly less safety systems than conventional light water reactors, because again, the ultimate hazard is less because of the fact we're operating at atmospheric pressure. And so this simplicity drives lowest cost. And then for me, the other side of cost is around how you can deliver it. So it's maximizing the benefit of modularization. It's maximizing the fleet benefits in your supply chain. It's driving, again, simplicity. So using standard products, using things that are off the shelf, not relying on one individual organization driving for value for money in different ways. and efficiency and effectiveness in how you repeat from project to project to project. You minimize the amount of engineering hours in each project, you minimize the amount of development hours in each project. So everyone in this space has got to be focused on doing that, and will be focused on doing that. But for me, fundamentally, we have the right ingredients to be in a position that our project costs will be competitive, or highly competitive, in the space of advanced modular reactors. Then if you combine it with the other opportunities, I couldn't possibly talk to you about what the price of hydrogen would be. I mean, that's so kind of too far disconnected from me at the moment. But at the end of the day, you come back to any other form of hydrogen that isn't produced by embedded nuclear is inherently going to be more expensive and less green. And anything where you're using lots of renewables which are grid connected, because they couldn't possibly be sort of embedded, because you don't get enough load factor from one kind of wind farm or one solar farm. You need the grid to stabilize it, backed up by some various energy storage plus the grid transmission systems. Whereas if you stick a small modular reactor next to a hydrogen plant and they're taking a direct connection, that is inherently going to be lower cost than it is to take it from the grid. So for me, that's the kind of fundamentals. And therefore hydrogen, if hydrogen is the source of transportable green energy that we need to decarbonize transport, that we need to decarbonize, and e-fuels to decarbonize air transport and other things like that, then inherently putting an SMR next to a hydrogen plant is going to be the lowest form of solution, or the lowest cost solution for that lowest carbon option.
So we've talked a bit about what's needed from the kind of government regulatory landscapes and the countries you're going to operate in. We've talked a bit about where you're at in terms of the plans and that pathway to the precursor plant, the demo plant. Let's just briefly have a look at the value chain around you, because I think one of the things I can sometimes be a bit naive about, and I remember the first time I heard about this on green hydrogen, but it is the need for a value chain to be developing at the same rate. Now, clearly, I imagine a lot of the kind of hardware and the tech and what you need is already in existence, because it will be either similar to or already used in other sectors. But is there any element of the value chain that is still kind of in development, or that you need to see rise up to support your plans?
Yeah, that's a great question. I mean, so we are aiming to be in all parts of the value chain. That's the first thing I would say. So there are some vendors of nuclear equipment who have been in the space of, we're going to develop equipment and we're going to sell it, and there's going to be someone that buys it. And we acknowledge that actually you have to create your own market to some degree, and therefore, if we need to, we will be energy developers. We will help seed projects and bring money into those projects, and we will as well, we are the designer of our own technology, but we will work with partners that are already established to complete that design and complete the R&D. When it comes to the equipment that we need to manufacture for our products, we're already actively making selective acquisitions in areas to create vertical integration in that equipment supply. So we bought companies such as SRS Fucina and more recently Rucci, which also bring in revenues to our group, which is also very positive. But they're organizations where there is an existing synergy and or potential future synergies around how do we build a robust and resilient supply chain for our products. SRS Fucina have expansion space potentially where you could look to build modular manufacturing facilities, for example. Rucci is a pumps business, and again, we have a need for capability in pumps and specifically around our lead technology. So there are natural synergies there, as well as having broader reach and base as a business within nuclear. So again, we also need to build a much broader supply chain than that. As I said, before, our reactor isn't a big, thick forging. And, if you talk about reactors, there is a much smaller supply chain around those specific components. Ours has the potential to be manufactured in many different places. And we're also not necessarily tying ourselves to any particular solution around, it's a modular solution, so we're going to have a modular factory and we need to build that before we can deliver our project. We aim to keep these things open. If we need to localize, we can localize. If we have a broader supply chain using existing organizations around Europe, then that's what we'll need to do, because first we're focused on demonstration, and then subsequently we both focused on industrialization. So it's a kind of step-by-step process. And then in terms of your point around markets, our first focus is power to grid. That simplifies that, right? Power to grid. We need, in the UK, there's existing arrangements for contract for difference or regulated asset base to provide some form of revenue mechanism, revenue price certainty to underpin investment. In France, there's an established mechanism for how the state works to determine the price that people get paid for power. In other European countries, there's a much more predictable, is the wrong word, a transparent energy market, where it's easy to see the average price paid for power, the forward prices paid for power, and that's openly publicized and seen. So I think if you then look to connect SMRs with these other schemes like hydrogen, where as you say, I've heard the same feedback, that for hydrogen to work, for carbon capture to work, you need the network, you need the mechanism, the pricing, as well as the consent, the investment. And you've got all of these different dominoes that, is that the right word? These different things that need to be lined up for that to happen. And I think one of the things that nuclear could potentially do in these kind of more complicated, multifaceted schemes is if we can create an SMR project that is grid connected, that can then be a linchpin that opens up these other opportunities that can come off the back of it. So for example, I've already got my power, so I don't need another connection. And so you need there to be something that can move first independently of the other aspects of a scheme, and then the other aspects of the scheme can hang off it. And I do think that at the right site, at the right scheme, nuclear can really be a catalyst for some of that broader infrastructure and low carbon investment.
Well, just to close us out, so we've heard a lot about the kind of mid to longer term objectives, and obviously on the scale of projects that you're talking about, that's of course where you need to be focused. But just to give a flavour for what you're focused on day to day, maybe what's the next 12 months looking like for you? What do you want to be achieving? Is it fundraising? Is it more focus on the actual sites? Do you expect to have those nailed down? What do you think the next 12 months has
it's
to
all
hold
of
for
those
you?
things. First and foremost, our business is focusing on delivering research, development, and design, and that's absolutely central for us as we move forward. As I've already mentioned, we need to secure the locations in France for the first demonstrator reactors, which as I've described, needs to be done in very close collaboration with the French institutions. We are actively fundraising, and we need obviously that money secured to allow us to deliver long term and keep pushing forward with confidence. So that's a priority. Linked to that, we are working very closely to ensure that our subsequent projects have location, so we can link them to location, that we can link them to country, we can link them to progress, and ultimately a route to market, as you've described. So we're working very hard on that as well in parallel. I guess those are the things you mentioned, but I think they are pretty much the key focus for us at the moment.
Well, thanks for talking us through that, Andrew. I think, as I said at the beginning, I know that the industrials who listen, and certainly the investors, and have a kind of familiarity with SMR and various parts of the nuclear opportunity. But I think it's just fascinating to hear about something that comes with that backstory of real circularity as well. I think getting that to market could be, I expect to hear a lot more excitement about that once you have some sites and projects that you're able to talk about more. But thank you so much for talking to us about that.
No, thank you very much. I would reiterate, I mean, it's a really exciting time to be in the nuclear industry. There's so much happening. Newcleo is also a very sort of agile and interesting organization to working at the moment. So I'm very pleased to be part of it, but I'm also very happy to talk to you today and try to share some of that shared some of what we're doing. So thank you very much.
Thank you.
At Jano Media, we recognise that great content has the power to create impactful and positive change for lives and society. Whether that's video, live streams, photography or podcasts, partnering with us will enable you to harness the power of content to engage, inform and inspire. Reach out to us today.